So the fourth one is thermal disruption. So by thermal disruption, what we simply mean is that at a certain temperature, it may lead to a reaction in which a base is being removed, nitrogenous base is being removed. So for example, deplurination occurs in certain thermophilic bacterial cells as a result of thermal disruption. So these are the 4 exogenous sources of DNA damage. So now we are going to be looking at the mechanisms. Now for these mechanisms, I'm going to create separate videos to explain them to ensure that everyone is able to understand. So because I believe everyone can understand these things. So the mechanisms. Now the first mechanism is direct reversal. So what it means is that the damages can be simply reversed. So for example, cross linkages have been caused by exposure to UV, for example, ultraviolet rays or radiation. Those can lead to certain pyrimidine dimers, as I earlier said. So they can also be chemically reversed through a process of photoreactivation. So photoreactivation requires an enzyme known as photolysis. So there's going to be a separate video to explain photoreactivation. Now, so we have direct reversal. After we have direct reversal, we have so depending on the kind of damage, for example, if it's a single-stranded damage, a damage to the single strand, then I'm sure if you have watched some videos on YouTube, you must have heard of base excision repair and the likes. So that falls under a single strand damage. So you have base excision. Excision, to excise, typically means to remove, right? To excise, to remove, right? Then under the base excision repair, we're talking about DNA glycosylases, and AP simply means apyrinic and apyrimidinic epiendonucleases. So I will explain more on that in a separate video. All right, then after we have this, then we have nucleotide excision repair. So nucleotide excision repair, base excision just means for just a base, and then nucleotide excision repair talks about probably 12 to 24 nucleotides. So it excises a bulk. So bulky damages can easily, for example, those pyrimidine dimerizations that cause those dimers between cytosine and thymine, most times they can easily be resolved by nucleotide excision repair. Then the next one is mismatch repair. So maybe during the process of DNA replication, mistakenly the wrong base was added. So there is a mechanism to repair that. So I'm going to explain these things later on. All right, let's go to the last one. The last one is the double strand damages. Now we have three. Let me use a different color. We have 3. The first is non-homologous end joint. This is more error-prone. You said that when there's a double strand damage, breakage or break. I think I should have used breaking for this. Break. So when there's a break, then it has to prepare the ends and rejoin them. So eventually it may lead to an error-prone system, an error-prone mechanism. So that's non-homologous end joint. I'm going to explain this later. And then you have homologous recombination. So one thing we need to know is that in all these processes, the complementary strand is always very important to kind of like store the information required for repair. So it's very important. And then in homologous recombination, I think that should be the homologous, the sister chromatid. The homologous chromosome is very important in this, in the sense that the DNA molecule on the homologous chromosome will be used for form of homologous recombination. So homologous recombination. Then next one is this one is quite new. It's rare in most textbooks. Microhomology mediated end joining. So I'm going to explain this later. So I think this is it for DNA repair and damage. I would really like to appreciate everyone for wonderful comments, the appreciations and encouragements and support I've gotten from every single person. I'm really grateful. But I would just really like to, encourage you to subscribe. Subscribe, please. Subscribe. Let me get some likes. Let me get likes for this video, and also share this video with your colleagues, and make sure you watch as many of my videos as you can. So I'm here to serve you, and I'm here to teach you. Have a wonderful day. Bye.